One of the main things that makes aerospace structures stand out from other structures is that they mainly consist of thin sheet material. This was not always the case. Early aircraft structures used the concept of trusses. Airframes were initially made of bars, tubes and wires, such as in the Fokker Spin or Spider. The bars, tubes and wires would carry all the load. The skin or fabric did not contribute to the load-bearing function. So what I have here is a square wooden frame with hinges in each corner. You can see now why truss structures are widely used in construction, because the frame as it is will not keep its shape under a horizontal load. Instead, it will become diamond-shaped. By adding a diagonal bar from the bottom corner to the top corner on the other side, we can get some structural rigidity. This concept of triangular frames is called a truss. Truss elements transfer loads primarily in tension and compression. If we were to extend the truss to 3D, it can also deal with bending and torsional loading. If the diagonal of a truss is a bar, it can be loaded in tension or compression. But if we use wires, we can only load those in tension. Which means we would need to use 2 wires, each strewn diagonally to ensure loads from both directions can be sustained. Truss structures are still used in aerospace, only more inside of structures to transfer loads, such as ribs in wings or in the center section of an aircraft. It's also used a lot in space structures. However, it is hardly used anymore as the primary structure of a fuselage or a wing. As aircraft design evolved, a shift occurred from fabric-covered trusses to metal sheets which had load-bearing capability. The advantage is that sheet material can also carry shear, whereas a diagonal rod or wire can only perform this function in tension or compression. If we were to put sheet material in our frame and load it, we can see that the sheet carries load and that it starts to buckle a little bit. Another advantage of sheet material is that it can also seal the structure from its surroundings. This is beneficial for use in integral fuel tanks and pressurization of the fuselage, both of which you would like to be liquid and airtight. In summary, sheet material can carry multiple loads: tension, compression, shear and pressure or out-of-plane loading needed to seal a structure.